Alrighty, our first question was just kind of I'm going to say it's a generic one about using various ways to mess with KP. So your equilibrium constant when it's in terms of pressure units. And yes, it's exactly the same as you would do for KC, right? So KP is just exactly the same, except it's in units of pressure instead of in units of concentration. So you can use it just the same way as you did before. So if you were to reverse here, you end up getting the inverse of it. If you end up doubling your reaction, you do end up with the square of it. And so you're going to see that the manipulation of these would be the same. If you were to multiply two or add two equations together, you would end up multiplying their KPs together. So exactly the same as all the other stuff you can do with KC. So cool. Alrighty, and then with that, there's also kind of the question about distinguishing KC from KP using the comparing the units. If we were to take our favorite equation, that's going to be two ammonias, right? Yes. All these are gases, of course, but if we were to write Kc, it would be the concentration of ammonia squared, concentration of nitrogen, concentration of hydrogen squared, cubed. If we do that, we would get molar squared over molar to the fourth, so that would be molar to the negative 2 power. If we look at Kp instead, we would have the pressure of NH3 squared, pressure of nitrogen, and the pressure of hydrogen cubed. If we do that, we would get some sort of pressure unit. For Kp, of course, you can use torr, millimeters of mercury, whatever, it doesn't matter. Some pressure unit as long as they're all the same. So if we're just given the units, can we tell Kp from Kc? You bet. In most cases. So Kc will always have some sort of molarity unit associated with it, molar to some exponent. Kp will always have a pressure unit. The only time that you're not going to end up with having the two be different units is if they are if your equation will just be kind of having the same number of moles on each side. Oops, not each side. So if we take a look at that hydrogen and iodine one before, Kc would be I2 times H2 over Hi squared. You would have no units. So if you didn't have units, you might have problems telling Kp from Kc, but depending on your reaction, in this case, they would be the same, right? Kp, Kc would be the same because they have the same number of moles of gas on both sides. So generally, yes, you can tell very easily by the units if it's in terms of concentration or pressure that your constant is also in terms of concentration or pressure. So there's not necessarily a canceling out unless your reaction happens to have the same number of coefficients on both sides, but I hope that kind of answers that. So the answer there is yes, it is definitely possible to compare the units. So if you're looking at pressure units, it's Kp. If you're looking at molarity units, it's Kc. If there's no units, it could probably be either one. So cool. All right, so 35 part A. Okay, we can do that one. Let's have a look. Where is my book? Actually, I have this printed out. 35. Okay. Alrighty, let's see here. So I've got the homework here. We have, let's just write our equation first. We have 2 nitric oxide plus 2 hydrogen turns into N2 plus 2H2O. All of these are gaseous. All right, it's telling us we're placing 0.1 moles of NO. Since this is in a 1 liter vessel, the moles are going to be equal to molarity, so I'm just going to omit that unit right there. For hydrogen, we're given 0.05. And then we're also putting a little bit of water in here as well. But no nitrogen, it seems. All right, and then the equilibrium is established, at which point NO is 0.062 molar. So that's kind of the information we've got here. This would be our ice table. So we would expect, presumably because there would be more reactants in this case, and we also know that we're decreasing our concentration of NO, that we're going to be making products. And having this information, having the equilibrium value here, we can see that 0.10 minus 2x is going to be equal to our equilibrium concentration. And so doing so, we'll see that 2x is going to be equal to, let's see, 0.038. And therefore x is equal to 0.019. Hopefully the math is right there. I'm doing it in my head, but that's what I get. And so doing so, we're going to see that we're going to have 0.031. We're going to have 0.019. These are all in concentrations of molar, or units of molarity, by the way. And this would be a 0.138 for our water. And so that's how you would end up calculating those, since we're already given the information here. So just a couple things to remember, that your coefficients do matter with these x's. So just make sure that if you have a 2 in front of your substance, that you're doing 2x for it. If your coefficient was 4, you do 4x. And yeah, other than that, that's how you should kind of solve that problem. And then hopefully part B, you can figure out how to do the equilibrium constant. You would just use these concentrations. So cool. Hopefully that helps. All right, and then Kevin has a couple of questions. So practice exam, we're looking for number 4B. Okay, let me actually pull this up then. From the kinetics one, I think. Let's see. So these are in terms, yeah, I mean, you should end up with having the same amount, because if you notice, like, all of these coefficients here, you know, in this case, they happen to, in fact, be exactly the opposite. So, yeah, we're definitely seeing the exact same change happening on the other side here. So, for sure, yeah. And so if we were to like add these up, I would hope that their molarities would all add up nicely together. Let's see, that would be 0.25. And that's 0.5. Yeah, I think these do add up as well. So yeah, they should. So, yeah, cool. I mean, yes, that's technically another way you could probably do it, but I mean, I guess that works. I mean, that's really all we're doing with this minus 2x plus x stuff anyway. So it's all there. Okay, so let me pull up this exam here. So 4B, second page. What is the slope of the second order reaction? Okay, so here's our reactions. If we plot their like integrated rate law forms, we see that zero order, first order, second order will look like that, right? And then we also have their equations. So since this one is asking for the slope of the second order reaction, we know that it's 1 over A is equal to KT plus 1 over A naught. We can see here that the slope should just be K. And so that would just be the answer. We can see here, again, it's a straight line. It's positive, so that's where that positive bit comes out. But the other two are negative. So the slope of these ones would be negative K. But for second order, it's positive K. So that's the only one that has the difference. If you look at the other equations, like this one would be ln would be negative kt plus ln of a naught, right? So that's where we're going to see the negatives in there as well. Okay, so the answer for that should just be positive k, which I hope is what they've put here. Let's have a look. They've highlighted negative k, but that's not correct. That must be a typo. Because second order, we can clearly see it's a positive number. Like, so I think that just might be a typo on that answer key. So definitely positive k there. Okay. Oh, okay, good. So I'm glad that we came up with the same thing. Yeah, for sure. So, I mean, just looking at the equation, it's definitely a positive value. So, cool. Awesome. All right, in that case, let's see. Number 12 is next. 5, 6, 7, 8, 9, 10. Wow, this is a long exam. All right, so we have 5 moles of aluminum ions, 5 moles of mercury ions, dissolved in a liter flask, blah, blah, blah. 27% reacts with mercury to produce aluminum. Calculate Kc. Okay, so let's copy our equation down here. Plus 2 aluminums. 3 mercury 2 plus. And then 2 aluminum. Solid, yeah. Okay, so we're putting 5 mole of each of the ions in there. Somehow that seems really something unlikely to be soluble at that concentration, but whatever. So it's 5 molar for both that we're starting with. And it also tells us that 27% of the aluminum will react at these kind of things. So that tells us because aluminum is reacting that we're going to be producing products. And we also know that we're using up 27% of it. So that tells us we're going to have that 5 minus 2x is going to be equal to, I guess it's going to be 73% of the remaining one. 0.73 times 5. Let's see if that math is right. So we're using up 27% of it, so we should have 73% left afterwards. Hopefully that part makes sense. If you do this math, let's see what we get here. Hopefully I've done this correctly. Let's see, 0.73 times 5. And then we're going to subtract 5 from it. And then divide by 2. We get x is equal to 0.675 molar. What did this question ask, by the way? It asks for Kc. Okay, so we just need to find the equilibrium concentrations. So 5 minus 2x is going to be equal to 3.65 molar. And then 5 plus 3 times 0.675 is going to equal, let's see, 3 times 0.675 plus 5 is 7.025. Just kind of ignoring sig figs for right now. We'll keep in mind that actually I think we just have one sig fig for all this stuff because they only gave 5 in the question, which is awful. But whatever. Okay, that's molar. If we look at Kc, should be mercury 2 plus cubed over aluminum 3 plus squared. Guess I should put brackets. Remember, we don't put liquids and solids in there, so we're just putting our aqueous bits, aqueous and gases only. So let's go ahead and plug in those values. So we have 7.025 on top. That's cubed. Oh. And then 3.65 squared on the bottom. Let's see what we get. 7.025 cubed divided by 3.65 squared. We get 26.02. Units would just be molar for this. I'm not really sure about the sig figs because it just said 5, which is a terrible number. I mean, technically we would round this to 30, but I'm thinking that this particular instructor is not as strict about sig figs as I am. So it should be around 26, I guess. But with the values that were given, it would be 30 with one sig fig. So, which sucks. But that's what that is. So cool. So without rounding, I'm just going to go ahead and circle that for now and not even worry about sig figs here. Okay. Does that work, Kevin? And then 15. Cool. There's probably other ways to solve this. I haven't actually looked at the key. Let's see. Where is number 15? Or 12, rather. There isn't a number 12 in the key. Oh, well, I guess that's why you would need to ask, huh? Okay, well, whatever. In that case, let's go ahead and look. So it says here, problem 6, which I believe refers to the problem before it, would increase the value of Kc. Alrighty, so let's go ahead and look at these. We have calcium carbonate turning into calcium and carbonate. We're given 3 choices of what to do, basically. If we add acid to react carbonate, what would that do? That should lead to using up products, right? So if we remove that product by reacting it, we're going to end up shifting to the right. But shifting to the right will not change our equilibrium constant, right? We will have to, we're getting rid of carbonate, so we're going to need to make more to reestablish our equilibrium constant. So this doesn't change our equilibrium constant. Next one is add an anion with which calcium is insoluble. So essentially we are removing calcium. We're going to get the same thing, shift right, but that does not change Kc. Same exact reasoning. We're removing one of our ions, our products, so we're going to make more products in order to reestablish that equilibrium. Next one is increase the temperature. And it says this is endothermic. Okay, so if it's endothermic, we have heat as a reactant. So if we increase the temperature, we're going to shift right. But notice our concentrations of calcium and carbonate we're already at equilibrium. We're not messing with those concentrations. But by shifting it to the right, we're going to end up producing more of those as a result. So this will in fact change your Kc. Just by virtue of the fact that we're putting in a reactant that isn't a part of our equilibrium constant. So normally if you put in a reactant, that reactant should be used up, right? Or the reactant that you're giving extra would be on the bottom of your equilibrium expression, and therefore increasing it would decrease your Kc. But then the products would balance that out. This time, all we're doing is making more products, but we have no kind of extra reactant to kind of mess with that. So we will, in fact, be changing our equilibrium constant here. And we remember that equilibrium constants do depend on temperature anyway, so we already know that changing temperature will mess with your equilibrium constant. So kind of just, another way of explaining it. Since this one specifically asks if it will increase Kc, yes, this will increase it because it's an endothermic reaction. We're pushing it to the product side. More products means bigger Kc. If we had more reactants, it would mean a smaller Kc, right? So in that case, that's what we're looking at. So it does look like there's a number of typos on this practice exam. Hopefully that's not something that is detracting from this. Let's take a look at the key here. So where do we, what does it say is problem 15? Oh, well, here's the mercury one. How interesting. Okay, well, anyways. Oh, yeah, look, we calculate that differently. Anyways, yeah. It's definitely written as a different problem number in the answer key there. So it says number 7 and then refers to problem 6, which is the calcium carbonate one. So yeah, it just looks like there's a little bit of inconsistency there, but at least the problems are there. So yeah, cool. Alrighty, awesome. Any other questions on that? Let's see. I think that's it there. All right. Well, in that case, we're done for now. You have 2 homeworks that are coming up due. I don't think I've put any lab sims out due, but your stuff will be due on Sunday night. Your answer keys will be available on Monday. Please look those over just to make sure that you're getting the concepts correctly. And then on Tuesday will be your exam. So there's not going to be any lecture on Tuesday. Ugh, there's a fly in here. No lecture, no stream on Tuesday for you guys. And so it'll just be your exam. So it'll be 6 questions. You choose 5 of them to do. If there's multiple parts like A, B, C, you have to do all of them for that question. So you'll want to choose which 5 you're going to answer. There is no benefit for answering a 6th one. If you answer all 6, I will just grade the first 5. So that's all that will be. I will try and give you guys feedback on your exam. We'll see. There's more of you in the class than I had anticipated at the start, so I'll hopefully be able to have the time to actually put all the individual feedback in. But we'll see. So, and of course I will put up an answer key as well, so you'll be able to see that before I grade stuff. So, yeah. Alrighty. Cool. Well, if there's nothing else, if there's any more questions that come up over the weekend, throw them in Discord. I'm happy to answer them. Don't forget your homeworks are due. Don't forget to show your work. A number of you haven't shown your work. I hopefully am pretty clear that I expect all your work to be shown on homework, and I definitely expect the same on your exam. If you're just putting answers out, you're not going to get credit for it. So I have to see what you're doing in order for you to get some points. So, all right. Of course, since this is going to be a free response exam, there will be partial credit. So even if you get something wrong, still do as much as you can on a question. And yeah, I'll try and include directions for the kinetics ones if you're going to have to use Excel. I'll ask you to write your equation out or something, just so like I can see what you're doing there, or to like sketch your graph, or something like that. So that'll be up for you guys. So cool. Alrighty. Well, if there's nothing else, I'll see you guys later. Honors people, I guess I'll see you in about 45 minutes, or 50 minutes rather. And then the rest of you, I'll see you on Wednesday. Wow, a whole week pretty much. Alrighty, well, with that, enjoy your holiday weekend. You've got is it President's Day, I guess? And then we also have Valentine's Day. Have so much fun. You're going to have your homework as your Valentine, as you should. Hooray. Okay, so this is going to go in Discord. Alrighty. See you guys.